Greetings, students. My name is Irvin Howard. Welcome again to EMH Math Portal. I'm serving as your EMH Math Portal online math tutor. And we're still looking at the series, the properties of exponents. And this series will focus on exponents. Now, like our last lesson, we focused on the product rule. Now today we're going to look at the quotient rule for exponents, and I've written down the definition and what procedures to write. And notice that we're still looking at A as the base, and any number, this time A has to be a non-zero real number, and M and N are non-zero integers, okay? Non-zero integers. Then A raised to the power M divides A raised to the power N equals to A, which will represent the difference between M and N. So in this case, we're going to subtract between exponents. We're going to subtract the exponents. So when we're dealing with the quotient rule, we write it according to the formula A raised to the power M minus N. And here's some examples that I'm going to give you. I'm going to just give you a few examples. For instance, example, you have 5 raised to the power 5 divided by 5 raised to the power 3. Okay, and then we're going to set this equal to. Now, 5 is the base right here, along with this base that's in the denominator, and the numerator has the same base, but the two numbers, the two non-zero numbers or the two non-zero integers are different. So according to the rule, when we have a quotient rule, quotient between exponents, we perform a difference between the exponents. So we're going to write it according to the formula. Going to write the 5. Now it's important that we recognize how the letters or how the numbers will work in sequence, because according to the formula, we're going to use M minus N, and we have to stick with that. So we're going to have 5 raised to the power of 5 minus 3, and then we perform the operation. 5 raised to the power of 5 minus 3 equals to 2. And then if we simplify 5 squared, or 5 raised to the power 2, that will equal to 25. Okay, I hope everyone understands that. It's very simple. And it doesn't really need too much to be a rocket scientist to figure that when you're having quotient between bases, you're going to subtract the exponents. Okay, let me give you another one. I'm going to give you, let's try the abstract letters. Let's try the coefficient, the letters. All right. Let's say, well, we'll try the variables. 5, x raised to the power 5 over x raised to the power 3. All right. Now, again, the variables are unknown. They're not going to really have any value. So what you will remember that you're going to still write the variable in respect to what the number could be. All right. But you'll still perform the operation. All right. So we have your quotient between the bases. All right. So we will take the difference between the two exponents. So we have x raised to the power 5 minus 3, which equals to x raised to the power 2. All right. Okay, and let's try one more. We'll still try another variable, and just to show you that there's no difference in between them, we're going to try the y. Y raised to the power 6 over y raised to the power 3. All right. So you have the quotient between the two exponents. All right. You have the bases as long. They'll still be the same. As a matter of fact, the bases must be the same if you're going to perform the operation between the exponents, especially when you're dealing with the quotient rule. So we have, excuse me, y raised to the power 6 divided by y raised to the power 3. And this equals to y raised to the power 6 minus 3. Notice that I'm still writing the formula. All right. That equals to y cubed. All right. I hope everyone understands, and I will continue to do more examples dealing with the properties of exponents. And we're going to continue to work with the properties until we finish all of the properties of exponents, and then we will do problems that will combine all the properties at once. Well, thank you for joining me at EMH Math Portal. And this is Irvin Howard, serving as your EMH Math online tutor. And I hope you have a great day, and life is worth living.